if you've got a few boxes already, or you've worked anywhere that's got some HPC that's got a queue, then parallel cluster is going to feel very much like, is going to feel very homely. But except there's probably not going to be any queue, because it's just going to spin up a new machine and start solving.
In all the companies that I've worked with prior to AWS, storage was always one of the main issues. In that, you're constantly having to delete files. You couldn't save certain things. There was emails flying around that, you need to delete by this date, and that's whether you're on an academic supercomputer or you're just in a company one. And as you say, I think that is one of the things that I like about running on AWS, is that I never worry about the storage, which is now coming full circle, because if I have all of my simulation that I've ever done, and now I'm looking at, maybe I can train a deep learning model, I'm like, great, I have all the data. I think compute is a big one, and it's probably the one that people think of, isn't it? Oh, I'm going to use the cloud because I can access, lots of compute. But I would argue that the storage is as important. Have you seen that as well?
Yeah, absolutely. Yeah, so I've been a kind of fairly heavy S3 user since the beginning, because the reason, so the way I kind of structure my process is to upload my local, so I'll kind of put files together locally and then upload them to S3, and then typically take them over to EC2. But if I don't do that immediately, that's not a problem. So I think for a little bit I was uploading directly to EC2 instances and what have you, which just didn't make a whole heap of sense. So yeah, I've got a lot of stuff on S3 in various tiers, and it invariably, when you do the maths about, so if I do want this data, I could run it again and get it back, but the amount of time I can keep it in, more recently in Glacier, or in kind of deep freeze on S3, I can keep it around for quite a while before it costs me more to store it than it does to rerun it. So I've got far too much stuff in there, but it's really not a big deal. I've always kind of looked at that. So coming from a background where you had a load of compute in the other room and there was a queue and you were all fighting over it. The thing with running on-demand instances, for example, is that the queue disappears. So it doesn't necessarily matter that one job let's say it takes 12 hours to turn around. Two jobs don't take 24 hours to turn around. I fire up another instance and it takes 12 hours to turn around still. 25 jobs still take 12 hours to turn around. So at a point, you get to the point where you're outcompeting much bigger machines in terms of turnaround time. And the turnaround time, if I can turn around, typically for me, if I can turn around a case, or multiple cases, but if I can, any given case, if I can turn it around overnight, that's about as quick as I can deal with the results coming back in, because I need to probably do something with it, particularly if I've got multiple cases. So what you're actually turning, you wake up in the morning and there's 25 results to deal with. That's enough, that's fast enough. Being able to turn them around, being able to explode it out so that it only takes 5 minutes doesn't really give me a lot, because I can't cope with it that fast. I can't react. I can't digest it and make the next modification or do anything with that result at that speed.
But what's been the biggest evolution then? So you were using AWS in 2011. What have you seen as being the key milestones? Like, do you see a big difference now? Are there any things you can identify as like, oh, when that came out, that was big for me, or when that came out, that was...
The things that stand out to me would probably be the way parallel clusters evolved. I think back in CC2 days, there might have been like a star cluster or something like you might have. Yeah. It's super easy now to spin up a little cluster. And so probably that, combined with the fact that you can, in those days, it wouldn't matter how easy it was to string a load of machines together, it wasn't worth doing. Two machines did not go twice as fast, whichever ones you strung together. Yeah. So for me, it was never, it was never kind of worth paying extra to go a little bit faster, and that's what it was. It was a little bit faster. Whereas now, I still kind of scratch my head and with the graphs that you guys put out and whatever. It's like, is it really the same? Does it really not get any more expensive? And it doesn't. And
do you want us to crank up the price?
No, I don't want it to crank up the price. But I kind of struggled with that, because you think, oh, we're going to go faster, we're going to pay more for that, and that's not typically the case. So parallel cluster, I guess EFA then, that's kind of enabled that ability to cluster them up properly, and I do most stuff on the Graviton instance on ARM now.
I guess this is where you're interesting, because you've done it for a long time. It does take time to get used to it, doesn't it? It's just a new way of doing things.
So one of the things that I say, if we're ever having these kind of conversations, is it really is not particularly difficult to spin up an instance, put one of your jobs on it, and see what it does. You can take some cents per core hour for a graph. That's a valid thing, and it's a good sort of high level thing to do. But go put your own work. You'd spend less than a couple of days, sort of, rather than in the hypothetical. Go and answer the question. Go and put one of your cases on an instance, or a couple of different instances, and then you're going to know how much it's going to cost.
Put on a couple of instances. It's going to cost you probably the same as a 6-pack of beer to give this a try.
Exactly.
Yeah.
Even if you were doing it wrong, to get that kind of ballpark idea of how this is, what does this really look like from what do I have to do to run on AWS? Does it feel like a comfortable thing that I'm going to kind of be able to work with? And stuff like parallel cluster, if you've got a few boxes already, or you've worked anywhere that's got some HPC that's got a queue, then parallel cluster is going to feel very much like, is going to feel very homely. But except there's probably not going to be any queue, because it's just going to spin up a new machine and start solving as soon as you submit your job. Getting to that point, there's a few steps, but it really isn't as daunting as it might once have been.
If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works, and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.